Okay, so this is part two of the stream which I kinda left in half. And this half we'll be like covering the mistakes which this guy pointed out here in the hardware channel. This guy was really helpful. He told me about like how I can use the VBus pin to directly like power the RGB lights and will actually get 5 volts and it will not stutter. He also recommended me to add capacitors to each one of the RGBs so that it does not flicker. So that will also be a good suggestion. Um and a push button for the run pin, so I don't have to manually remove it every time I want to debug. So that's also great. Looks like a lot of stuff which I can improve. So let's get started already. We'll close this code. We'll come to KiCad. We'll close the PCB editor for now because we have lots of new changes in mind. And also I thought about adding an OLED display because the structure here it looks kind of uneven, like in the PCB editor you might have noticed. This is kind of uneven. If I try to draw a PCB like this, that will be so I'll add a small OLED display here, which will make it look a bit more clean. Now that we are done discussing what we are going to be doing in the stream, let's not waste any more time and get started. First, I'll be removing this 3-volt supply, which is causing some pain. Yes, we removed that 3-volt supply. Also, we're removing this VBus because we want to connect it directly through that VBus. So we're done with that. And now, yeah, we'll have to draw a new system here, which is my bad. We'll choose a screen here actually. First, we'll choose a I2C module or something. So let's look for I2C. These are bus controllers. So let's just go like SSD 1306 306. Thing is, I'm getting the 0.91-inch version, which I don't really want. I want the other 0.96-inch version, which I don't seem to be finding anywhere. I'll have to install the library, but I'm still confused about what library to install. So like I tried installing the library for the recommended screen OLED display, but I couldn't figure it like how to get it into KiCad. Now it only shows me this OLED display, which is 0.91 inches. It's ER underscore OLED M 0.91 underscore 1x. So we want to see, which is I don't think will be applicable to our standards. We wanted a like slightly bigger one, which is also like a square and not like this shaped. So yeah, what should I do about it is the question I should be asking. So we'll probably look for the library somewhere here. I'm live, right? Hopefully I am. Yeah, I do not want that to go to waste. Now thinking about it, 0 point. Mm, the thing is, we don't really have footprints for the screen itself. We only have footprints for the pins for like most of the cheap modules which I am looking for. So like we'll just go to the footprint assignment cool or something. Uh, One sec. So we'll be looking for already existing symbols. So let's look at the actual documents for this one. Uh, I don't think this will match my question, but yes, footprint library display. It's like we have a lot to look for here. We have a 1.3-inch display. Looks sure does look complex. I just wanted a normal picture of it, man. So let's look for a normal picture of it. Why is it it's not supposed to be $20. So we'll look for a cheaper one because I don't want to spend my entire life savings on it. We look at the price, that's probably the only price we find. Find these normal ones, and we also have this RoboCraze one, which is good, but it's not that. You get OLED displays. We look for OLED. No, that's wrong. OLED. Looks like we only have one more OLED display. This is simple enough, and I'm pretty sure this one will support all of our OLED ones. So let's look for OLED and KiCad. This is not the OLED which I wanted, and that does not look like a symbol at all. We'll take a screenshot of this and we'll actually look for something. This by itself looks quite scary to me because let me Google search. We will ask ChatGPT what this is. So, um, looks like normal display to me. I might as well use it then. It's not gonna make much of a problem for me. So let's pump this display in. This right here, yes. And let's keep it like this for now. It's just a normal one, not going to change a lot. I'll keep this a bit here. Uh, Down. Yes, that will do it, I think. Yes. And now to connect it to the actual pins, just add power simple, we'll add a ground. Yeah. I hope those two don't merge. Then we will add a 3.3 volt here because we're gonna be using the 5 volts for the RGB. We'll add a 3.3 here by the way. So this is working. We have the 3.3 and the ground attached. And for this 3.3, we'll just rotate it here. Not the VCC, the 3.3. No, spot alone. Yes. So now that is done. What is the SCL and what's the SDA? SCL stands for serial clock time. Clock time which provides the timing signal for data transfer. Okay. Hmm. So both of them are that's the question we should be asking, and we will ask that. While that is like okay. So both of them are to be connected to GPIO pins. Great. Now that we know that, we will be doing that later. First, let's add our 5 volts coming out of here. We'll add a power 5 volts, 5V. And we'll add another 5 volts here. So now this should be working fine. And now he also told me to add what capacitors to each and every one of them. So I'll have to be looking for symbols here. C small. Yes, and polarize so I can do whatever I want with it. This is gonna take a while to fit all of them, and yes, keeping the capacitors aside, done with the capacitors for now. I mean, not done with the capacitors at all. Let's complete this first, the OLED module. Mm, 1 second. Yes, we are back. So 5 volts has been connected, and 3.3 volts has been connected. Ground has been connected here. Now we'll be adding capacitors. So we'll add 9 small capacitors. Uh, GPIO opens will attach them. Remove these two. Now I'm back with my mic. We'll be adding small capacitors to each of these RGB ones so that they will not flicker, hopefully. I hope that the capacitor actually acts like a small storage tank. So let's add our capacitors again. Where is it? Yes. Now control copy, control V here, control V here, control V here, control V here. It's not supposed to be like that. Can it be like that? I think so. So we'll move this a bit here. Control C, control V, control V. I will. Hmm. We'll move this here and then go this one here. Nice. Looks like we have quite a good structure. We'll have to reverse the power grid a bit. That is, we'll do is we will draw some wires here. Oh shoot, looks like we won't have space for our lasso. Done. And now no, stop. Now this will probably be changed a bit. I just realized that made no difference. That was kind of dumb of me. We will do that again. It's just a normal straight connection. It's not supposed to happen. Done. Now that that is done, we have to connect this here. Both of them looks uneven, but we don't care. We are engineers. That's not supposed to be a joke, but still, looks like this lasso wire is going around. Nice. That has been connected. That's good. And then we also have our GND here. I just realized, shouldn't all of the capacitors also be connected to the GND? Shit, that's a bad mistake which I made. Do all of the capacitors we use have to be connected to the ground of the no. Oh, that's great news. Let's check this for once. The ERC that is. We are getting a lot of errors. Input power pin not driven by any output power pin. um power pull, not runway. Let's look it up. What does it mean? Maybe here. Does not explain a lot. Here it because KiCad requires every power input pin, the CMD or IC, to be electrically driven by a power output pin on the same net. The power supplied via a connector, battery, or external source rather than a voltage regulator output pin. KiCad entire cannot verify the power source and generates this violation. So I'm pretty sure that fix will be done by drawing a wire around this, I think. Looks like we are getting the same ones. If I remove the 5 volts here, will it do something? We're getting it directly from the Weber's. If I remove this, and if I put the 5 volts here, now save this and check the ERC. Holy smokes, that's another error. So let's remove this and then we'll put a cap here. Looks like this was never the problem. I have to redo the whole thing. It's the capacitors which are the problem. So first we will connect this to a power source. Done. This error is gone. Looks like we still have the error for all these. Oh yeah, why is there a small capacitor here? Move that. We'll get rid of another error. Actually, two errors, okay. So we have 9 capacitors, and all of them are showing an error. So what do we do? Probably gonna think about it, like how can we solve this though? Hmm, like okay, capacitors don't work like that. Hmm. So these two. uh, Once I fix these errors, I'll be going into the PCB editor, but only if I am able to fix them though. So, input power pin not driven by any output power pin. Isn't it already getting like it inputs the power? Should it be like the opposite direction? Wait, I'll rotate one and see. It's non-polar though, right? Okay, we'll save this. That's not the problem at all. It's like I'll have to put a power flag then. Flag. Yes, I'll be putting it here, and I'll remove this. Hopefully this will solve the problems. Fingers crossed. Wow, that was supposed to take away my problems, but it gave me more. So now, is that how a power flag works? I'm not really sure. Uh, like I'll have to put it somewhere here. Mm, it's already getting it, so move this. Still don't get it. What's the problem here? Like the thing is, I'm still getting the problem. Like putting the power flag on the point, on the 5 volt line, and it's still giving me like the same errors, and I'm not really sure about what I should do. I already tried replacing the 5 volt line near the V bus. I like the 5 volt it's there. I connected a wire into the V bus, and that gave me another extra error. I did the same thing here near the RGB points, and it gave me the same error. And yeah, I don't know what to do anymore. So tell me what I should be doing with the power flags. Like I don't get it. Is like we should probably ask the Slack though about this. This guy was really helpful. We got the yeah. While like we are thinking about this, we can actually run the small 100 enough capacitor. That's the one I'm using, right? Hopefully it is. Hmm. Please work this time because this is probably the only thing which I can do about it right now. Hmm. Hmm. We'll be skipping this part. We'll first. Yeah, I'm kinda giving up on that. But we'll remove this small thing and we'll add a button here. What button this guy recommend me? A small, okay, push button. So button, not power supply symbols. Let's go to here. Uh, that's not the switch I wanted. Just a push switch. And yeah, wait. Hmm. However, the flag should be solving our problems, so I'm still not getting like why is it not solving the problem? I mean this obviously is kinda wrong. And this is definitely most definitely wrong, but I guess I'll have to do some research about it and come tomorrow because it's already 10:57, so I'll have to stop the stream for now. Well, like that's it for today though, folks. I'll be working on it a bit off screen, and I'll come out with a solution by tomorrow. So today we added, the RGB. We added the switch, like the push switch, which will let us like change the run. Should actually be connected to the pin 30, but yeah, I'll change that as well. And yeah, we got into the PCB editor. We assigned a footprint and did some connections here and there. So I'm pretty sure the schematic will be ready by next live stream and we'll get into the PCB editing. So as soon as the PCB editing is done, I'll order it and we'll start building it IRL that will give me like golden koi, which I really need. It's really fun though, like it's inspiring. Tells me to, like I have a like I have to get 120 hours worth of progress to actually get a good amount on the travel stipend. So I guess it's a good excuse for me to stop procrastinating and actually do some work.